Hey guys, and welcome to a new video snippet. Today I will show you how to build a Ventuz scene that supports the depth image capabilities of a Kinect camera. In my case I used the Xtion by Asus, which is integrated very similar to the Kinect by Microsoft. The Xtion provides some libraries that must be installed to get the camera running. When done, there are two middleware libraries installed that we need for our purposes. OpenKnee, which can read out the depth information of the camera, and OpenNight, which provides skeleton capabilities based on this information. When you want to use such DLLs inside Ventuz, they must meet some requirements. Firstly, it must be a 64-bit C# DLL. Secondly, it must have a public key so you can add it to your global assemblies cache. Since the OpenKnee and OpenNight libraries both do not meet those two requirements and there's no way to get around that, we must find another way to pass the information we get from the camera to Ventuz. The idea is to write a standalone .NET application that uses the two libraries needed to get all information from the camera. The application then sends the gathered info via OC packages to the Ventuz scene. Here we can now process the data inside the scene logic. Most of the work inside the .NET application is specific to the Xtion. Basically, a thread constantly updates all data we get from the camera. This includes the depth image and all skeleton joints that could be identified. The main thread then sends OC messages when the Xtion recognizes the user, when it has calibrated him or her, and when it has lost the user. These messages also provide a user ID for Ventuz. Additionally, the application sends OC messages on each frame of the camera to provide the skeleton joint positions and the depth image. Inside Ventuz I created a script node. The script firstly starts an instance of the OC application. When the script is destroyed, the application is closed again, so you don't have to do that manually. We get the depth image by creating an OC dispatcher, which listens on a specific port of the network interface. The dispatcher reads out all OC messages and updates the script node's output properties accordingly. Since the output properties of a script may neither be an image nor a two-dimensional array, we provide the depth information inside a one-dimensional array. Also, we only use 16 by 9 pixels of the image to prevent too much data to be processed inside the scene. This can be done since the visualization has no higher resolution than that. The rest of the scene contains rather simple bits of logic to visualize all the data that we get from the OC application. That is the bar chart on the right, which shows where the user is horizontally, and the panel on the left, which shows the state of the user identification and the positions of the hand of the first user recognized. This is it about integrating a camera with a depth sensor. I hope you get an idea of how to approach this, and I will see you in our next video. See you then, bye!